So now the next board is on BUM traffic handling in VXLAN. What is the meaning? So first thing first, this name is quite funny, BUM, right? BUM. But if you were in my switching class, then you must know that we have discussed about it. B in BUM means broadcast, U means unicast, and M means multicast. And you all know that how this traffic is handled by a particular switch. So if I talk about a normal switch, how it is going to happen? Suppose this switch is connected with host A, host B, host C, and host D, suppose, and the traffic is coming from, say, host X, and these are also the MAC addresses. Okay, so what is going to happen? Suppose we take an example of a message which is coming from this host X and wants to go to host A, right? This is my layer 2 message. If it comes here, what is going to happen? Switch will check its scan table, and if it sees the entry that yes, A is there right there, it is going to forward it. This is how unicast message is forwarded over a switch. You all know about it, right? Everybody knows about it. Now, let's talk about a broadcast message. What is going to happen with respect to this broadcast message, right? Now, suppose a message is coming from this host X, but wants to go to all F. All F means it's a broadcast message. Maybe it's an ARP message. It is coming from here, right? What is going to happen? Switch will see this is a broadcast message. It means that it is going to flood it across everywhere except on the port where it has received it. As simple as that. Now suppose this is how switch deals with the broadcast message. The U means unknown unicast message. What is the meaning of unknown unicast? Suppose a message is coming from source X and wants to go to maybe E, right? And this E is not known to this switch, means its MAC address is not present in the switch table. If that is the case, this message will be coming here. Switch doesn't have any idea about the destination MAC address. And if that is the case, what switch is going to do? This switch will actually forward it in on all the ports except the one where it is received. Means the unknown unicast messages are also flooded by the switch, right? They are switch treats them just like the broadcast message. And if we talk about multicast messages, what is going to happen? Suppose a message is coming from X and it wants to go to a multicast address. You should know that there are the group of multicast MAC address, or there is a range of multicast MAC address. And if that is the case, if this reaches here, if you haven't done anything on this switch, believe me, this switch is going to flood this multicast message to everywhere except from the port where it is received. So broadcast, unknown unicast, and multicast, by default, switch treats them and behave and forward them equally. Means it is going to broadcast unknown unicast as well as multicast. You all know about it. But yes, if you have enabled IGMP snooping here, it means that you are making this switch more aware, and this multicast group represent these two hosts, then switch will become intelligent and it is going to forward this message only to these two hosts, this one and this one, right? So why I'm talking about all this? If you have missed my switching class, believe me, we have discussed all these things in great detail there, right? But we need to understand how we are going to handle the BUM traffic in case of VXLAN. And this is going to be very interesting thing, right? So what is happening, guys? We have a VLAN 10 here. And this VLAN 10 is mapped to VNI value 5010, right? On all the switches. Here also VLAN 10, 5010. VLAN 10, 5010, right? And this clever guy, intelligent guy, is looking all this mapping and it is creating a table that, okay, 5010 is mapped to 3333, right? What is the meaning? There is some mistake here. I just want to say that this smart guy is really intelligent, and it is building its table, and it is saying that on VTAP 3.3.3.3. But before explaining this table, I need to introduce another term which is known as VTAP. What is the meaning of this VTAP? right? So you all know now that these are my spines and these are my leaf switches, right? And you all know that if host A wants to communicate to host B, they will be making a tunnel here, right? And this tunnel, I can write on top of this tunnel that this is actually 5010 because VLAN 10 is mapped to this. And if I see the end of this tunnel, then at the one end we have switch 3, at the other end we have switch 5, right? It means that these are the end points of the tunnel, right? So switch 3 is actually the end point. End point of what? End point of virtual tunnel. Or sorry, a VXLAN tunnel. And that is why we known as VXLAN tunnel endpoint, right? Or I am slightly confused with this term. Can anybody please check what is the meaning? This is virtual tunnel endpoint or VXLAN tunnel endpoint? You can raise your hand and give me answer, right? Maybe. So what does it means? If that is fine, means virtual tunnel endpoint or VXLAN tunnel endpoint, I am not sure on that. Just have a look at it, right? But the whole sole point is the meaning of VDAP is these are the endpoints of this tunnel. Tunnel endpoint, absolutely, right? And these tunnel endpoints can be identified by a loopback address. For example, switch 3 is what? Switch 3 is a tunnel endpoint, right? And I can identify a switch 3 with a loopback address, which is 3.3.3.3. So effectively, I can say 3.3.3.3 is my tunnel endpoint. 4.4.4 is my tunnel endpoint, right? And this clever guy or the intelligent guy is creating a tunnel, sorry, it is creating a table in which it says that VTAP or tunnel endpoint 3.3.3 has VNI 5010. It is also noting that 4.4.4 tunnel endpoint is also having 5010 and 5.5.5.5 is also having 5010 VNI value. Interesting. Now, let's move an R packet, right? You all know that the address resolution packet, till now we have discussed one thing, right? And Mr. Rahul to everybody is saying that it is a VXLAN tunnel endpoint, and thank you so much, Mr. Rahul. It's a VXLAN tunnel endpoint, okay? So ARP is a broadcast message we all know. And now what is going to happen? Suppose host A wants to communicate with host B, and it is writing a ping message, ping 110.10.10.20. If that is the case, we know the IP address, but we do not know the MAC address. And that is why we are generating an ARP message. And I know that what is there inside the message ARP. I think you all should know. Inside this ARP message, there are 4 fields: sender MAC, sender IP, target MAC, and target IP. Sender MAC is going to be my MAC, which is AAA. Sender IP is 10.10. Target MAC, I do not know, and that is what I want to know, and that is why this message is ARP request message. Target MAC is going to be all zeros because I do not know about it, and target IP is going to be 10.20, right? This is this green message, whatever I have written in this red. This is inside this green message, right? But if I want to send this ARP message over this wire, I need to put a Ethernet frame over it. And that is why I'm putting my own MAC address A, and I will be broadcasting it FFF. Very, very interesting. This message will be received by this host switch 3. What is going to happen next? This guy knows that the message is coming from VLAN 10, and it is my duty to send it to all the hosts in VLAN 10. This is how a switch behaves, right? Remember how switch behaves with the broadcast? It is going to forward it on all the interfaces access which are in that VLAN and on the trunk interfaces which are in that VLAN, right? You all know about this. Because you never know that the destination might be present over the switch 4 because switch 4 contains VLAN 10. Why? Because switch 4 has this VLAN 5010. It might be behind switch 5, you never know, and that is why you need to send this ARP to everybody where this VNI 5010 or VLAN 10 is there. But in layer 3 environment, we do not have VLAN numbers, we have only VNI number, and that is what I'm doing here. I am putting this ARP message, this layer 2 message inside layer 3. But before doing that, I need to put the VXLAN number, and that is why I'm putting the VXLAN number. And I know after that what you need to do. You need to put source IP and destination IP, and that is why you need to ask this control plane, Mr. Control Plane, where I need to send it. And control plane is saying that you need to send it from 3.3.3, which is your IP address, towards 5.5.5.5. And of course, you need to send it towards 4.4.4.4 also. Very, very interesting. It means that one message should be going out to 4.4.4.4. Why? Because there is a VNI 5010 there. This message should also go towards 5.5.5.5 because there is a VNI there too. As simple as that. Right? Interesting. Now, consider this switch 3. What it is going to do? It is taking an ARP message, right? It is writing the VXLAN VNI there, which is 5010, and putting it inside an IP packet. But now there is not one packet which will be going out. There are going to be two packets, one towards 5.5.5.5, the other towards 4.4.4.4. It means that this switch 3 needs to create two packets, not one, right? And here is my problem. Suppose right now there are only three leaves, switch 3, switch 4, and switch 5. What is going to happen if we have 100 leaves here, right? 100 leaf switches, or maybe 200, maybe 1000. It means that this switch 3 needs to create a copy, right? It needs to create a copy for every VTAP, right? Where it is going to see this 5010 VNI. Maybe out of 1000 leaf switches, if you have 500 switches which are having this VNI configured, which is 5010, it means that switch 3 needs to create 500 copies of this ARP message, encapsulate it into the RP, and send it. Believe me, when you recreate the message, it takes some time. It takes some CPU also, right? And by the way, this process is known as ingress replication. Why? What is the meaning of ingress replication? You are receiving, switch 3 is receiving a message, right? It is coming towards it, it ingress to it, right? And that message is actually the bum traffic. Out of the bum, it is specifically the broadcast. If this is the broadcast, it should go to everywhere where this VNI is there, right? 5010. If that is the case, it is going to replicate it. It is replicating the ARP message, and that is why the name is ingress replication. Very, very interesting, right? Ingress replication. So you should all understand that actually, if you are sending an ARP message, actually switch is replicating it. But is it the only way to send this message? Right? So there are two ways to send this message to multiple destinations, right? One is ingress replication, the other one is multicast. And that is why I taught you multicast before this course. Because we will be using multicast and underlay heavily when we configure VXLAN with EVPN. And some people say that EVPN doesn't require multicast at all. This is not the case, guys. EVPN does require multicast or maybe ingress replication in certain specific scenarios. And I will be letting you know those scenarios, right? But there are only two ways to send the multicast or to send this message to multiple destination. One is through ingress replication and the other one is through multicast. Multicast is way more efficient if you have so many switches. If you have so many switches, then this responsibility of replication should be distributed, should not be on one switch. And if you understand multicast, you know that in multicast case, switch 3 will be sending just one packet, and it is the responsibility of this network, the complete network or the spine network, to replicate this message, right? This is way efficient than ingress replication if we have lots and lots and lots of access switch, if we have huge data center, right? So there is no doubt about it that we can send this ARP message from here to here now towards 5.5.5, and we can send this message towards 4.4.4.4 over the VNI, which is 5010. There is no doubt about it. So the message is received at the switch 5. But now the question arises how the switch 5 is going to reply it, right? Although I have already talked about ingress replication, but I have made a specific board for it. But in this board, what I will be doing, I will be actually explaining you how the ARP reply message will come, right? By the way, you should understand the ARP request message is a broadcast message, right? But when we receive ARP reply is always a unicast one, because the destination know where to send this message, right? We all know about it. But how this thing is going to work in VXLAN environment, believe me, this switch 5, if I consider this is the switch 5 table, suppose it is maintaining another column here which says MAC address. What is going to happen here, right? Okay, let's talk about it. So what will happen here is this host is sending ARP. You all know about it. The ARP message will be encapsulated in the VXLAN, which is 5010, and the source IP and destination IP will be, I need to put it here, right? It will be going over 4.4, it will be going over 5.5. I am talking about a message which is going from 3.3.3.3 to 5.5.5.5. This message will be going here, and from here it will be coming here. As simple as that. What is going to happen when it reaches to 5.5.5? It will be opened, right? Because destination is 5.5.5, the message will be opened. But in this IP packet, we have the protocol field which says this is not the final packet. Inside it, we have a VXLAN, and I will be showcasing you this message in the workshop, believe me. Inside this, there is a VXLAN message, and this is the VNI 5010. Switch 5 will say, okay, VNI 5010 map to my VLAN 10, because some intelligent guy has configured this on me. If that is the case, I need to forward this L2 frame in VLAN 10. Here also the same thing will be happening, but we have 10.20 here. This guy is going to reply back. But see what intelligent thing this switch 5 is doing. Once it is receiving this message, right? This message, it is receiving it from where? It is receiving it from 3.3.3.3, right? And this message is coming with the source address of source MAC of AAA. So can't it say that VTAP 333 has MAC address AAA? Very, very interesting, right? Absolutely, it can. From this message, the switch 5 can definitely create the entry in its table. It can say that VTAP 3.3.3.3 is having MAC address AAA. Absolutely, right? Why it is maintaining this entry? It is maintaining this entry. I will let you know. Now the ARP message is here. Once the message comes, it is open, FFF is gone, AA is gone. The ARP will be right here, right? How this message is going to be for now, 10.20 will be creating ARP. Sorry for this. I should, yeah, ARP reply. The source of ARP reply is going to be BBB. And it knows where to send it. It knows it needs to send it to AAA. And interestingly, once it is reaches to switch 5 also knows that AAA, to send this message towards AAA, I need to send it towards 3.3.3.3. It doesn't need to ask to anybody, and it is going to put the VXLAN, VNI, of course, 5010, and then the source IP and destination IP. The source IP is going to be 10.20, the destination, sorry, the source IP is going to be 5.5.5.5, and the destination is going to be 3.3.3.3, because A.A.A is behind 3.3.3, right? You do not need to broadcast this frame, and this frame can come from here to here. This is how the ARP reply will come back. And now the subsequent communication, the communication after this, the ping message, right, which we were not able to create because we do not have the destination MAC address. Now we have the destination MAC address. Now we have that complete ICMP message, which I was showcasing you from last 3 classes. I know how to make that message now completely, right? Interestingly, right? And by the way, again and again, I'm saying this intelligent guy will become your BGP EVPN, right? Because what do we need now? We need this information that which VTAP has which VNI, right? And believe me, this information can be distributed by BGP, right? We want to know here which MAC address is behind which VTAP. This information is also given by BGP. You all must be knowing that in BGP, right, we can send IPv4 routes, we can send IPv6 route, we can send multicast routes, we can send BGP, VPN, V4 routes. You all know that if you have seen my MPLS class, you must have seen the address family concepts. BGP now can send MAC addresses also. Believe me. Very